Vanakkam. Now we are going to solve problem 3.17 using nodal analysis from Fundamentals of Electric Circuits by Alexander and Sadikis, 5th edition. So this is the problem. So we are asked to solve this electric circuit using nodal analysis to find current I0. So here we have this current I0 flowing in this particular path. So this is the first node and this is the second node with the potentials V1 and V2 respectively, and here we have taken this as third node with the potential V3, and we mark the currents here as the I1 current, and this is I2 current, and this as I3 current. Already this I0 is given, okay, and this is taken as the reference node with the zero potential. And here we have this 3I0, that is dependent current source is also available. This voltage source of 60 volts is also available. Okay, so if you look at this V1 is equal to the 60 volts. Now we'll solve this using nodal analysis, so that we have to apply KCL at node 2. So at node 1 we are not going to apply this KCL because here this 60 volt is available. We don't know how much current is flowing through this. Okay, so if you consider this V1, the current flowing through all the paths which are connected to this particular node must be known to you, okay, or you must be in a position to write it. Okay, here we have only 60 volts voltage source, so we cannot take this particular node, so we consider only second node as well as the third node. We know how to apply this KCL, Kirchhoff's current law. It states that sum of the incoming currents is equal to sum of the leaving current. So when you consider this second node, here what are the currents which are coming inside? This I1 is entering and this 3I0 is entering, this I2 is leaving. I1 plus 3I0, that is equal to I2. So instead of I1 I can write it like, by applying Ohm's law, V1 minus V2 divided by that 10 ohm resistance plus 3 into this I0 can be written as V1 minus V3 because it is flowing right here. So it is flowing between this V1 and V3. So divided by that 4 ohm resistance, that is equal to I2. So I2 is flowing between this second and the third node. So it is V2 minus V3 divided by this 2. So here you can cancel out this, and 5, this is 2, this is 1. Okay. So when you take the common denominator here, so this is 2 times, right? So 2 into V1 minus V2 plus this is 5 times, so it becomes 15 into V1 minus V3, that is equal to V2 minus V3. So we can write this as 2V1 minus 2V2 plus 15V1 minus 15V3, that is equal to cross multiplying this. Okay, so it is 10V2 minus 10V3. So rearranging the terms, we have this 15V1 as well as this 2V1, so it can be written as 17V1. Then we have this 10V2 can be brought to this side, so it is minus 10V2. Along with this 2V2 we get this as minus 12V2 minus 5V3, that is equal to 0. And we know already that this V1 is equal to 60 volts, isn't it? So I can substitute it here. So it is 17 into 60 minus 12V2 minus 5V3, that is equal to 0. So 17 into 60 is 1020 minus 12V2 minus 5V3, that is equal to 0. So, right, this is 12V2 plus 5V3, that is equal to 1020. This is our first equation. Now we have to analyze the third node. So at the third node, we can apply again KCL. So incoming currents are I0 and I2. So this I0 plus I2, that is equal to the leaving current I3. I0 can be written as this V1 minus V3, okay, divided by 4 ohm resistance, plus what is I2? I2 is V2 minus V3 divided by this 2 ohm, and I3 is V3 by 8 ohm resistance. Okay. So when you take common denominator as 8, this should be multiplied by 2. So and so this is 2V1 minus 2V3, plus this should be multiplied by 4, right? So it is 4V2 minus 4V3, that is equal to V3 by 8. So we can cancel out this 8 and 8, so that we can rewrite this as 2V1. Instead of V1, I am going to write or substitute the value of 60 volts, and V2 is plus 4V2, and V3, if you combine all this minus 2V3 minus 4V3, this V3 is also coming over here, so we get minus 7V3, that is equal to 0. So it is 4V2 minus 7V3, that is equal to minus 120. This is our second equation. So we have the first and second equations here. So when you multiply the second equation by 3, we get this as 12V2 minus 21V3, that is equal to minus 360. So let's take this as 2 dash. So now we are going to subtract this 2 dash from the first equation, and we get this as this by changing the sign. These two get cancelled, and here we get this as 26V3, that is equal to 1380. So what is V3? V3 is equal to 1380 divided by 26, that is equal to 53.07 volts. And we are asked to find out I0 only, right? I0, what it is? It is V1 minus V3 divided by that 4 ohm resistance. So it is equal to 60 minus this 53.07 divided by 4, that is equal to 6.923 divided by 4, that is equal to 1.73 amps. So our answer is I0 is equal to 1.73 amps. This is the required answer. Okay. Thank you.